Hello friends, this video on surface area and volume part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. The question says a cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter of the hemisphere we can have? And we have to find the surface area of it. So let's first draw a diagram. This is the diagram looks like. This is a cubical block, all sides 7. This is a cube actually. On this cube, there is a hemisphere surrounded. The first question is what is the greatest diameter of the hemisphere we can have? So you can see from the diagram also that the greatest diameter will be the length of this, correct? Or length of this. Both are 7 actually. Both are 7 only. So we can say that greatest diameter is 7. Why? It makes explain once again. See, this is a, consider this as a square actually of 7 by 7 height. Don't get confused with the 3D figure. Consider this as a square of a 7 by 7 height. We'll take this top view only. On this we are supposed to draw a circle here. So if we draw a circle here, actually, the maximum diameter we can draw will be 7 only. Correct? Because this is 7. Here also if you see, the maximum diameter is 7. So it will be, diameter is maximum 7. Had this been cuboid, if you see, that has been different figure. For example, this is a cuboid, rectangle, which this has 4 and this has 8. Now the maximum we can draw is 4 only, this much. So it will take the minimum of length and breadth. But in this case, both are same, so it will be 7 only. Correct? Because if we are supposed to draw a circle on a rectangle which is 4:8, then the maximum diameter we can draw is 4. But in case of the square, both are same actually, the maximum will be 7. Correct? So we'll take minimum of the length. So minimum of the length in case of 4 and 8 is 4. In the case of 7 and 7 is 7. So the greatest diameter is 7 cm. First part is done. Now we have to find the total surface area of the solid. Here there is a trick actually. So if you observe this, we can't just add directly. That we can't say that total surface area is surface area of this figure, the hemispherical figure, plus surface area of the cuboid, or cube. We can't do why? Because there is a common area. I'll put in red. This area is a common area. Correct? So when I put this hemisphere on this cube, this area is hidden. This area is hidden. So we need not find the surface area of this. We have to find only the surface area of the portion which is in white. So this portion is hidden. So if you say like this, if you say surface area of figure is equal to surface area of cube plus surface area of hemisphere. So surface area of hemisphere is this curved part. Surface area of cube is the whole one. But if you see, the red part also comes, the surface area of cube. And that is something which is internal, which is not viewed. So we have to subtract this. So we have to subtract this. So this is wrong actually. So in this we subtract base of hemisphere. And that is surface area actually. Surface area of base of hemisphere. Correct? Now if you see, surface area of the cube is nothing but six into side square. Surface area of cube. Surface area of hemisphere is nothing but 2 pi r square. And the base of the hemisphere, this is nothing but pi r square. How? Because the radius is r. Correct? This is the radius. And base of the hemisphere is circle. And the area of circle is pi r square. So in this figure, if you see, the side is 7, let me write here, side is 7 and the radius is how much? 7 by 2. You see, the diameter is 7, so radius is 7 by 2. We'll put the values here. So this becomes 6 into 7 square plus 2 pi r square minus pi r square become pi r square. So this becomes 22 by 7 into r is 7 by 2 into 7 by 2 gets cancelled. This becomes 11. So this 7 square is 49. 49 into 6 is 294 plus 77 by 2, right? 77 by 2 is 38.5. So this becomes 332.5. Now since we are talking about surface area and we are talking about centimeters, so it is centimeter square and that is my answer. You understood what we have done? We found the surface area of cube, we found the surface area of hemisphere, we found that there was this part, the base of the hemisphere that is hidden, and we did not find the surface area of this. So we subtracted the surface area of the base of the hemisphere. Let's take one more example very similar to the same example. Here also a hemisphere depression is cast. So instead of the protruding figure, it's a depression here now. From one face of the cubical wooden block such that diameter of the hemisphere equal to the edge of the cube. Determine the surface area of the remaining solid. So I'll show the figure. This is the figure actually, it looks like. Here is a cube. It doesn't look like cube, but actually it is a cube. So the length of the cube, the side is all L actually. This is L, and this is also L. Now from this, a hemispherical depression is cut. And this radius is L by 2. So we can say that side is L for cube and radius for hemisphere is L by 2. That is what the question says. There is a cubical block, side L, L, L. From this, a hemispherical depression is cut and where the radius is L by 2. Diameter is L, so radius is L by 2. We have to find the surface area of the remaining solid. Here also if you see, this area is not there at all. So earlier the base area, this base area we are talking about was there, but it was hidden. In this case the area is not there because it's all air here. So what we have to do? Here also we have to subtract this area. See, what we can do is we can find the area of this whole cube. From this we subtract the area of this hollow area. What we'll get all this white part, and then we'll add this area of the hemisphere. Then we'll get total area. Understand this? So you get the area of the whole cube, you get everything. But from this part is not there. So we subtract this area. So you'll get the area of the whole cube actually, the existing cube. And then we will see that this part is also there. So you'll add this area. See, for solving the area problem, you have to understand the figure. If you don't understand the figure, you will not be able to solve the problem. Here you have to understand why it is like this. Don't just mug up, try to understand. In this case, it's a cube of side L, L, L. Correct? From this, a hemisphere is cut. Now in this case, since it is cut, this area is no longer there. This area I'm talking about, or I'll put this area in red. This area I'm talking about in the shade is not there. So we'll subtract this area. Now we subtract this area also, we'll get what we have added till now is this white portion only. This portion is something which we have not added. So we'll add this also. So let me write this. Surface area of figure is nothing but surface area of cube minus surface area of base of hemisphere plus surface area of hemisphere. Correct? So now if you see, surface area of cube is what? 6 into side square, L square, minus surface area of the base of hemisphere is what? pi r square. And surface area of the hemisphere is what? 2 pi r square. So what we get? 6l square plus pi r square. Let me write r also in the terms of l. This becomes pi r is nothing but l by 2 square. So what we got? 6l square plus pi l square by 4. So we will take 4 common. So this becomes actually 4 here, 24l square plus pi l square. So we'll take 1 by 4 l square common because that is common across. So this becomes 24 plus pi. And this is the unit is not given actually. It is not there told that is meter or centimeter. So we'll say unit square. Why square? Because it is surface area, and that is my answer. See, the questions are simple. The only thing is you have to understand the figure. If you understand the figure, you understand which area to subtract, which area to add, which area to ignore. You have to just apply the basic formulas. Surface area of cube, surface area of cuboid, hemisphere, and then get the answer. We'll take some more examples. The more question you solve, the better will be your understanding. This is what. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.